Hello everyone. Today I will discuss and show you how to solve the first assignment in a progress modeling and simulation course. The question to be solved by Simulink are two irreversible reactions where A goes to B with a reaction coefficient constant K1, followed by B going to C with a reaction coefficient K2 with a duration of 5 minutes. Note that B is an intermediate and C is the final product. Also, the reaction rates follows a simple first-order expression as shown. Likely, the material balances for the three components are given as shown on the worksheet, and they are what we will build in Simulink to solve the problem. Also, K1 and K2 values are given to be 2 and 1 minute to the power -1 respectively. Now that we have read and understood the problem, we will solve by using Simulink to obtain a graph of the change in reaction rate with respect to time. To begin, open MATLAB, then click on Simulink to launch to Simulink browser to begin the fun. Simulink start page will pop up. Click on blank model. From there, it will take you to a new page. First, I will write the material balance of A. I will maximize the font a little bit. Then in the top left, I will click on the library browser. Then click on the commonly used blocks. I will drag an integrator block and rename it as dCA by dt. And set the initial condition to 1. According to the problem, Ca0 is equal 1 mole per liter. Then drag again a block and rename it as K1. Then double-click to the block and insert the value of K1, which is -2, since A is a reactant in this case. Then add a scoop block in front of the integrator to display graph of the function. Now connect all arrows between the tools. Since we would like to multiply K1 with the integration of integration block, link the back arrow of the gain block to the arrow linking the integrator to the scoop. From here, we will move on to stage 2, where B is a product of A and a reactant to produce C. First, I will write the material balance of component B. Then, from the library browser, I will drag a new integrator block and rename it as dCB by dt. Then double-click to the block to make sure its initial condition is set to 0. According to the material balance of component B given in the problem, we must multiply Ca from the forward arrow of dCA by dt arrow by positive K1. So I will add another grain, then I will double click on it and set its value to +2. Then the second part of the material balance of component B is to subtract K2 multiplied by Cb. So I will add another grain block and I will rename it as K2. After that, I will set its value to 1. It will be more convenient to flip the block. So I will right click on it, then I will click on format, then flip a block. Afterwards, I will add a scoop block in front of the integrator. Finally, to complete the material balance of B, I will add a sum block in between K1 gain block and the B integrator. And I will set it to be positive negative rather than positive positive. Now I will connect all the streams in a logical way to assemble the material balance of B. From here, we are left with the last material balance equation of the final product C, which is simply the multiplication of K2 to CB. So again, I will write the material balance of component C Then I will add a new integrator block. And I will rename it as dCC by dt. Followed by a scoop block. Then simply connect the K2 block to the inlet of dCC by dt and connect the back arrow of dCC by dt to the scoop. Finally, our solution is complete and we have reached the final steps. To view the resulting graph, add a max block. Next, set its number of input variables to 3. Then follow it by a last scoop block. Now connect all the previous 3 scoops to the max block. Then connect the max block to the final scoop. To be more clear, we will change the foreground color for each one. Before we click on run, we will set the duration time to be 5 according to the worksheet. Now, when I click on the scoop, the graph will appear, which shows a decrease in A till it reaches a value of 0, while B increases, then decreases, since it is initially produced from A, but then consumed to generate C. Hence, C is always increasing because it is the final product. Thank you.